Hi, my name is Stephen Mogensen, and this is Shelter Animal Outcomes, my graduate student project for CSCI 29 Python for Data Science at Harvard Extension School. So this course was offered in the spring of 2018, and this is our teaching staff. So for my project, I decided to take on this challenge that was posted on Kaggle a couple years ago, using a data set of intake information including breed, color, sex, and age from the Austin Animal Center. I'll be trying to predict the outcome for each animal. So here's everything that's required to run the code. I used pandas and scikit-learn. The dataset is available on Kaggle, and the Jupyter Notebook file I'll be using is available on my GitHub page at this URL. Now I'll be switching to Jupyter Notebook code. Here we have all the imports that I've used, and here is a look at the data. So as animal ID, animal name, date time information, outcome type, this is the feature we'll be trying to predict. Outcome subtype, we won't be using this. Animal type, which is dog or cat. Sex upon outcome, age upon outcome, and breed and color information. And all these columns are of type object. So the first thing we'll do is we'll change the datetime column to an actual datetime object and drop the columns that we won't be using. And taking a look at the different outcome types, so these are the features that we'll be trying to predict. So we have adoption, died, euthanasia, return to owner, and transfer. All right, now let's take a look at the nulls that we have in the data. So we can see we have a lot of nulls in the name column and a few in these two columns as well. So with the nulls from the name column, we're going to try to capture that information. Creating a new column has name that captures whether or not the name is present, and then we'll be dropping the name column because we won't be using that one anymore. For the sex upon outcome column, we can see that there is an unknown value as well as nans, so we're just going to go ahead and fill the nans with the value unknown. For age upon outcome, there are no unknown values, so I'm just going to go ahead and drop the few columns that have nans for age upon outcome. All right, so now we can see we don't have any more null values in our data set. And now we're going to be doing some data visualization. So first, let's check the outcome distribution by animal type. So it looks like dogs are much more likely to be returned to their owner than cats are, apparently. And now let's check the outcome distribution based on whether the animal had a name or not. So you can really see a stark difference in adoption and return to owner rates between these two categories, as you might expect here. So now we're going to be looking at the sex upon outcome column. So this column contains information both on the animal's gender and on whether it is intact or spayed or neutered. So let's separate that information into two columns and consider spayed and neutered to be equivalent. Now looking at the outcome distribution by gender, the main difference we see is in the unknown category here, where almost none of them were adopted or returned to their owner. And looking at the outcome distribution by neutered status, we see that the neutered animals are much more likely to be adopted or returned to their owners, as you would probably expect. All right, now we'll look at the age upon outcome column. We're going to go ahead and convert that column into a number of days value. And looking at the distribution by age, we can see that younger animals are more likely to be adopted, more likely to be transferred, and more likely to die, interestingly. And older animals are more likely to be returned to their owners and also more likely to be euthanized. So next let's take a look at the date time information. So I'm going to go ahead and split this information up into season, day of the week, and time of day. So first, looking at the distribution by season, there's not too much variation here, but there is some. For instance, we can see that animals are less likely to be adopted in the spring. And looking at the weekday information, we can see here the main difference is a spike in adoptions on Saturday and Sunday over the weekend. So I'm actually going to go ahead and change that column a little bit to capture that, whether or not the day was on a weekend or a weekday, and simplify this a little bit and then drop the weekday column. And finally, for the time of day, we can see that more animals were euthanized and transferred earlier in the day, and there were more adoptions later in the day. All right, so finally, let's work with the breed and color columns. So here I'm going to create categories and then create new columns for each one to capture, for example, for the breed column, whether the animal is a mix, whether it's, for example, a short hair, long hair, medium hair animal, or different dog and cat breeds. And we're going to do the same thing with the color information as well. We're going to go ahead and capture the different colors that are in the data set. So now looking at our data frame, we can see all the engineered features that we've created. So here we can see the breed information, the color information. And finally, let's do some one-hot encoding to capture the categorical column data. And here is our final data column, or data frame, sorry. And here we can see the categorical data, so we can see season, cat and dog information, gender, and neutered status. So we'll go ahead and create a test train split where we train on 70% of the data and test on the other 30%. And here are a couple of helper functions for running our models and showing the results. And here's the first classifier that I'm using. It's a decision tree classifier, and I'll be using a grid search to optimize the parameters as much as possible. So using this decision tree classifier, I'm getting a 66% F1 score, and here's the confusion matrix for that. Next I tried a k-neighbors classifier, and I was able to get a 62% F1 score with that one. Then for the logistic regression classifier, I was only able to get a 60% F1 score, so a little bit lower for that one. Next I tried the SVC classifier, and I got a 62% with that one. Next I tried the linear discriminant analysis classifier, and again I was only able to get up to 61%, so again a little bit lower for that one. And then finally, with the random forest classifier, I was able to get as high as 66% F1 score with that one. So then I tried using a voting classifier, and I went ahead and used this with the 3 best performing classifiers and the best parameters that I had used for those previously. So that was the random forest classifier, the decision tree classifier, and the k-neighbors classifier. And here we can see I was able to get the highest F1 score yet by just a little bit at 67%. So this was the best I was able to do for this problem. And I feel like this is a pretty good accuracy considering that I was trying to predict between 5 different categories. I feel like that's a pretty good result. So, and here's the final confusion matrix for that classifier. All right, so that is all. Here are the references that I used, and thank you for listening.